Picture this. You're standing in Rudong, a coastal city not far from the bustling metropolis of Shanghai, China. The air is crisp, and as you gaze upward, you see a 40-story tower rising above the landscape, dominating the horizon. But this isn't a skyscraper filled with offices or apartments. It's something far more innovative. This is a giant battery, but not the kind you might imagine. Instead of storing energy with chemicals like lithium or lead, this tower harnesses the fundamental force of gravity. Here's how it works. Massive concrete blocks are hoisted skyward using surplus electricity generated by nearby wind turbines. When the wind is strong and demand is low, energy is stored by lifting these blocks. Later, when electricity demand surges or the wind dies down, the blocks are gently lowered, and the energy from their descent is converted back into electricity, feeding power into the grid exactly when it's needed most. This isn't just a concept or a prototype, it's happening right now. This is one of the world's first commercial-scale gravity batteries, operating in real time. For decades, the dream has been a world powered by the sun and wind, but there's always been a big question: what do we do when the sun sets or the wind stops blowing? How do we keep the lights on? This tower offers a simple, elegant answer to that age-old challenge. It's a bridge between the unpredictable nature of renewables and the constant demand for electricity. Imagine a giant cuckoo clock. When you lift a weight, you store energy, and as it descends, it powers the mechanism. The same principle is at work here, but on a scale never seen before. China's gravity battery uses thousands of these blocks, each one playing a part in powering entire neighborhoods and communities day and night. It's a testament to human ingenuity and determination, proof that we can harness the forces of nature like gravity to create clean, reliable energy for everyone. Why is this happening now? Because we're at a pivotal moment. Renewable energy sources are booming, but their on-again, off-again nature has always been a major hurdle to overcome. This tower is more than just an engineering marvel, it's a beacon of hope, lighting the way toward a sustainable future. It shows us a future where cities never sleep, running 24/7 on clean, reliable energy, free from the pollution and limitations of fossil fuels. Around the world, nations are racing to move away from coal, oil and gas. Gravity batteries could be the missing piece that finally makes renewable energy truly dependable. Renewable energy is now cheaper and more widespread than ever before, but the real breakthrough is in how we store and deliver that energy when it's needed most. This tower stands as proof that we can store clean energy at scale, making the dream of a green, resilient grid a reality. The future of energy might just be built on gravity, a force as old as the Earth itself, now powering the world of tomorrow. Renewable energy is amazing, clean, free, and abundant. Solar panels and wind turbines harness the power of nature, turning sunlight and wind into electricity without polluting the air or depleting resources. It's a vision of a cleaner, greener world that many of us hope for. But there's a catch. The sun doesn't always shine, and the wind doesn't always blow. Weather patterns change, and seasons shift, making renewable energy production unpredictable and sometimes unreliable. Our need for electricity, however, is constant. Cities never sleep, and our homes and businesses rely on a steady flow of power, day and night. But renewables can't always keep up with this demand. The grid must always balance supply and demand, second by second. If there's too little power, blackouts can plunge entire neighborhoods into darkness, disrupting lives and businesses. Too much electricity, on the other hand, can overload the grid, causing damage to infrastructure and risking costly repairs. Fossil fuel plants can be turned on and off to match demand, but you can't control the weather. Renewables don't offer that same flexibility. That's where energy storage comes in. It's the crucial bridge between intermittent supply and constant demand, helping to smooth out the bumps in renewable generation. Imagine a giant energy piggy bank. Store extra power when the sun is shining or the wind is blowing, and use it later when it's dark or calm. This is how we can keep the lights on, no matter the weather. Without scalable, reliable storage, a 100% renewable grid remains just out of reach. A dream, rather than a reality. Lithium-ion batteries have been the go-to solution, but they're expensive, rely on rare materials, and wear out over time. Mining for lithium also raises environmental concerns. We need more options, solutions that are sustainable, long-lasting, affordable, and made from materials that are easy to find and safe for the planet. The world's scientists and engineers are racing to solve this puzzle, collaborating across borders and disciplines to invent the next generation of energy storage. Gravity batteries are one of the most promising answers. They use simple physics, lifting and lowering heavy weights to store and release energy. These systems offer a way to store massive amounts of energy simply and sustainably without relying on rare minerals or complex chemistry. The challenge isn't just generating clean power, it's storing it efficiently, so we can use renewable energy whenever we need it, not just when nature provides. That's the missing link for a truly renewable future, a world where clean energy is always available day or night, and gravity, harnessed in new and innovative ways, just might be the key to unlocking it all. When most people think about energy storage, the first thing that comes to mind is the lithium-ion battery. These batteries have become the backbone of our modern, portable world. Lithium-ion batteries are fantastic for powering our smartphones, laptops, and electric vehicles. But when it comes to storing energy for entire cities or stabilizing the power grid, scaling up these batteries introduces a whole new set of challenges. The materials needed, lithium, cobalt, and nickel, are not only rare and expensive, but their extraction can be environmentally damaging and often involves complex global supply chains. Gravity batteries, on the other hand, rely on abundant materials like concrete, steel, and other resources that can be sourced locally. They don't require any rare metals at all. This means that almost any country can build gravity batteries, creating local jobs and supporting their own economies, all while avoiding the complications of international supply chains. And when gravity batteries reach the end of their life, their components, mainly concrete and steel, are straightforward to recycle or repurpose, making them environmentally friendly from start to finish. In contrast, lithium-ion batteries degrade over time, losing capacity and efficiency, and typically need to be replaced after about a decade of use. Gravity batteries are mostly mechanical systems, motors, winches, and heavy blocks that are built to last for decades with minimal maintenance. The concrete blocks themselves are incredibly durable and don't wear out, even after years of repeated use. While gravity batteries are slightly less efficient than lithium-ion batteries, typically around 80 to 85%, their longevity, low maintenance, and sustainability make them a compelling investment for large-scale energy storage. These systems are massive, designed for grid-scale storage and stabilizing renewable energy, not for your pocket or your car. The goal isn't to replace lithium-ion batteries, but to use gravity batteries alongside them, each serving its own unique purpose. By building a diverse energy storage ecosystem, we make our power grids more resilient and adaptable to future challenges. Gravity batteries offer a sustainable, long-term solution for storing renewable energy at scale, helping us transition to a cleaner future. They stand as a model of both sustainability and practicality, showing what's possible when we rethink how we store energy. The future of energy storage isn't about one technology winning out. It's about using the right tool for each job, maximizing efficiency and sustainability. And as we look ahead, gravity batteries are emerging as a powerful new tool in our clean energy toolkit, ready to help power the world for generations to come. Let's look at the EVX Gravity Energy Storage System in Rudong, China. This isn't a prototype, it's a full-scale commercial plant, connected to the grid since 2023. When wind turbines generate excess power, it's used to lift heavy blocks up the 40-story tower. When the grid needs energy, the blocks are lowered, generating electricity as they descend. The system can deliver 25 megawatts for 4 hours, enough to power thousands of homes. The blocks are made from local soil, sand, and industrial waste, cutting costs and cleaning up the environment. The modular design means it can be scaled for different locations. Developed by Swiss company Energy Vault with Chinese partners, it's a model of international collaboration. The Rudong plant proves gravity storage is real, scalable, and ready for action. It's already making China's grid cleaner and more stable, a concrete symbol of a new era in energy storage. Gravity batteries could transform the global energy landscape. They help us use more wind and solar, cutting reliance on fossil fuels and reducing emissions. Every megawatt-hour stored and released is one less from coal or gas. They promote a circular economy, using local, abundant materials and even industrial waste. At the end of their long life, materials are easily recycled. Unlike lithium batteries, they don't depend on rare imports, boosting energy independence. Countries can build their own storage, using local resources and labor. For China, this is a game changer, helping meet climate goals and leading a new global industry. By perfecting these systems, China can export the technology worldwide. Gravity batteries are a solution for the whole planet. Rudong's gravity battery is just the beginning. It's part of China's ambitious plan to peak carbon emissions before 2030 and reach carbon neutrality by 2060. Massive investments are going into renewables and storage. More, even larger gravity battery projects are underway, especially in regions rich in wind and solar. Government support is strong, subsidies, targets, and streamlined approvals. China aims to dominate the global market for clean energy infrastructure just as it did with solar panels. The vision, a smart, resilient grid powered by a mix of storage technologies. Gravity batteries will work alongside pumped hydro and lithium arrays. The scale and speed of China's energy transformation is unprecedented. These concrete giants are laying the foundation for a new energy era. Gravity batteries face real challenges. Upfront costs are high, building a 40-story tower isn't cheap. They need tall structures and space, which can be tricky in crowded cities. Efficiency is good, but not as high as lithium-ion batteries. Engineers are working to improve performance and lower costs. Public acceptance and regulatory hurdles can slow projects. Some worry about visual impact or construction noise. Community engagement and clear communication are essential. Overcoming these challenges will take technical skill and public trust. But the potential rewards are enormous. Gravity storage is a global idea, not just China's. Companies like Energy Vault are building projects in the US, Europe, and Australia. Designs are being adapted for different environments, even underground using old mine shafts. In California, rail cars are used. In Scotland, abandoned mines become giant batteries. Every country needs solutions for renewable intermittency. Gravity batteries are attractive, long-lasting, made from common materials and locally buildable. Developing nations can use local labor and resources, boosting economies and clean energy. As more projects are built, costs will fall and designs will improve. Global collaboration will accelerate adoption and set standards. The race is on, and the whole planet stands to win. Imagine a future where silent towers stand beside solar fields and wind farms. By day, they store excess energy. By night, they release it to power our lives. Energy independence becomes possible for every country using local resources. Industrial waste becomes a resource, not a problem. This isn't a distant dream. The technology exists now. Gravity batteries won't be the only solution, but they'll play a vital role. They offer longevity, sustainability, and abundance. It's a testament to simple, elegant engineering. We're learning to work with gravity, unlocking a clean future for all. The journey is just beginning, but the potential is limitless.